All right. So this is the honors unit 1 review. The first thing we're going to talk about is the units, the imperial units going to metric and back and forth and that sort of thing. So you'll get an answer or a formula sheet that has all of the conversions that you could possibly need. They're just given to you right there, like 1 mile equals 1.609344 kilometers. Okay? And you'll be able to use that in any kind of problem that we have. A typical kind of problem I'd ask you is something like this. I'd say, convert, this is so easy, like convert 3.98 kilometers to miles. This is a nice little like warm-up problem. So these are like the easier kind of problems I'd ask you.
So
Other ones would be like they'd be included in a harder problem.
So you do 3.98 times 1.60.
Yeah. So to set this up, you start off with 3.98 kilometers, and we want to eventually go into miles. And so we're going to need a conversion factor. In your little formula sheet over there, it tells you that 1 mile equals 1.609344 kilometers. It tells you that. It's in the little chart. So you multiply this by this conversion factor. You're using this conversion factor. So you can put either the mile on top or you can put this on top to try to cancel out this kilometers. So we end up putting the kilometers on the bottom.
Yeah, you
But
have
one
to
do-
put miles.
Don't you always have to put the 1 on the top?
You
You
don't
have to
always
put
put the one on
opposite
top.
ones on.
But in this case, we want to put the opposite. We want to put the kilometer unit in the denominator so that these can cancel out.
And you always want to do that.
You always want to cancel out the units, yeah. So right here it's 1.609344 kilometers, and on top it's going to be 1 mile. That's just that. It's just this conversion right here that I put into a factor, a conversion factor. And if you do this, it just turns out to be a division problem in your calculator. What is it? 2.07 miles? 47 miles. So this, is that the right number of sig figs too? Did you round it at all, or is it just turn out? Okay. So this is with the right number of
Is
sig
it
figs.
6 figs for this?
Of course.
So how many?
So she used the right number of sig figs. She already used it. She used a 3. 1, 2, 3. Always think about sig figs. Whenever you're reporting an answer, you put something in your calculator, you should just automatically think, okay, I'm putting something in my calculator right now. I'm going to have to round this some way because I'm not going to be able to report all those numbers that are spit out of my calculator. So you're going to have to round it some way. You look towards what's given to you in the problem. So in this case, we have 3 sig figs in the problem. So you're going to have to report the final answer to 3 sig figs.
So it doesn't matter what's in the current. Because there you have one.
It does not matter because these are what we call perfect measurements for our conversion factors. We didn't explicitly go over this in class, but those things, they never limit your sig figs. So all of these things that are in your formula sheet, they never limit the number of sig figs you have. So even if we have a number right here that has more than 1, 2, 3, 4, 5, 6, 7, more than 7 sig figs, it still won't limit your answer over here. And here, for 1 mile, you think of it as a perfect mile. It's exactly 1 mile. So it's 1.00000. That's it. And even though this is a weird number right here, that's not going to limit the number of sig figs you use.
Can you do one where it's like kilometers and do something and something?
Sure. I could do a more complicated one than this.
Yeah, we have to convert it like into 2 times.
Sure. Like the top and the bottom. Let's do a density one for that. So this covers factor label. It covers, we can do conversions to exponents. We don't really typically do that all that much, but we can do that right now.
And by exponents, I mean like where we have to do on one of the conversion functions, we have to do like 1 centimeter times 1 centimeter times like that.
Right. Okay, I got you. Let's do that. Let's do that right now. Okay, so we can do that. You want to do a difficult one, and then we can use it with the exponents. It'll be fun. All right. So let's do this. Let's take convert. I always start with 2. So let's do 75.1 grams per meter cubed to. Let's use this unit. So let's use milligrams per kilometer cubed.
Um,
So that's a really tough one because we're changing both parts of these units, both of them. So you have to really think about this in advance. You have to really think about what the heck these metric units are all about. Okay, you're going to use your conversion chart for sure. Let's start off with what it's given us. We have 75.1 grams. So we know right away that it's going to be limited to 3 sig figs, no matter what. 3 sig figs in our final answer. We don't even worry about that until we get to that final answer. So let's start converting stuff. Do you want to start? Oh, I forgot the bottom part. Do you want to start off with the grams or the meters cubed? Grams, okay. So grams, we're going to finally go into milligrams. At the end, we're going to make sure that it's milligrams. We can do that right away. Lucky for us. So let's do it. So what's the conversion factor for this?
1,000 milligrams over 1 gram.
All right, so 1,000 milligrams for 1 gram. Right. So if we do that, then we can cross off our grams, and we're left with this final unit right here of milligrams.
So we're done with.
So we're done with milligrams. We don't have to worry about that milligrams anymore, but we do have to worry about these meters cubed. Right. We want to go into kilometers cubed, which is a weird unit. So let's do that. I'll make this a bigger parentheses because we're going to need it. Need extra space. Okay, so kilometers cubed. A meter cubed is 1 meter times 1 meter times 1 meter. 1 meter. So I'm just going to write that up here. When we work with volume, I always break these into the different dimensions because a meter can be divided into 3 dimensions: length, width, and height.
And have you typed that into your calculator and get the right?
Oh, we're going to get to that. So this is, I put the meters on top because I know the meters, we need to cancel them out because we've got meters in the bottom here to start off with. We want to eventually end up with kilometers in the bottom. So for every meter, how many kilometers are there? There's 1,000. Okay, there's a couple ways you can do this. One way is to rewrite this before you put anything in the calculator. That's the way I do it, because that way you don't make any mistakes with the calculator. If you do it that way, you just add up all the zeros here. So I'm just going to do 1, and I see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So there's going to be 9 zeros here.
So then you put it in your calculator as well.
Yeah. So this number right down here, that's 1,000. It's going to be kilometers cubed. Okay. Does that make sense?
So then you could just multiply 75.1 by 1,000 and divide it by that number.
Right. But there's a mistake.
Well, where's milligrams?
Why isn't it? We already did it. It's in the first step.
What's the mistake here?
Where's the other milligrams?
Wait, what's
There's a mistake here. Where's the mistake?
Well, where's the other milligrams? It's gonna cross it out.
Milligrams? Cross out milligrams?
Grams, grams, meters, meters, milligrams. Then where's?
Yeah, those are the.
Oh, we want to
the
get
units
to
that you want.
kilometer.
We want to get to kilometers, yeah?
So how many kilometers?
So what's our mistake?
are
There is a mistake here.
Was this intentional? It's 1 meter.
It wasn't intentional, but it's a mistake. You see what it is?
Oh, doesn't
What?
1 never go on top?
It can if you need to.
Okay, well, yeah, I got it.
I'll give you a hint. It has something to do with this thing over here.
Could it be? Oh, another parentheses.
Not really. There's 1 meter for every kilometer.
No, it's the other way.
It's the other way around. Yes. Okay, so it's 1 kilometer for every. Oh my God. So it's going to be that many zeros on top. I'm just going to put that big number. It's going to be 1,000 meters times 1,000 meters times 1,000 meters. Here's-
Yeah.
Yeah. Okay, so this is going to be, this number right here is 1,000,000,000,000,000 meters cubed for 1, and this whole thing is 1 kilometer cubed. So I'm just going to write that down right here.
I have a question. How do you know what goes on? Wait, how do you know that goes on the top and that goes on the bottom?
I know that, okay, there's a couple of reasons. First, this measurement right here, this density, it has the meters cubed on the bottom, right? So to cancel out the meters cubed on the bottom, I need to put another meters cubed on the top.
Okay.
So that's how I know that these meters cubed go on the top. Now, I made the mistake, this was not intentional, I made the mistake of putting 1,000 kilometers for every meter. It slipped my mind. But I caught my mistake. I realized it when I said 1,000, or I said what is this? 1 and there's 9 zeros of kilometers. It's a billion kilometers cubed for 1 meter cubed. And I thought to myself, that doesn't make any sense because meters are much smaller than kilometers. Kilometers are huge. So there should be a ton of those things fit in to a kilometer, but not the other way around. So it's a nice way of checking yourself. Just to realize, okay, that's a big unit, and meters is a small unit, so there should be more meters in kilometers. Okay, so that's why these meters go on top, because you want to cancel these meters out. So you know that they're going to be going on top, and you know that there's a lot more meters than there are kilometers. So in 3 dimension, there's a lot more meters than there are kilometers as well.
So you just multiply the tops.
So you just multiply tops.
Is
So
it
this and this and
7.51
this.
to e to the 13?
Yeah.
So yeah, the final answer should be 7.51 times what?
0.51 e times 10 to the 13th.
Yeah.
Could you do another one? Because that
Yeah, that makes sense. And then this is going to be, the final units are going to be milligrams per kilometer cubed. That's a weird one. So that's several steps. That's a difficult conversion where you're using 2 types of units here. Right?
Yes.
Let's see if this is still going. Yeah. Sorry. Okay. This covers conversions of exponents. Let's talk about moles. Let's do a conversion problem with moles.
Can we do like one normal one, as in like one conversion factor, and then another one with like cupcakes?
yeah.
Oh yeah, because you know
Yeah.
there was that quiz once that you had a question of like miles and cupcakes. And
Yeah, 3.8
Is
moles.
there gonna be a question like that?
It might be.
Obviously.
Convert 3.8 moles of what? Of a cookie. Cupcakes? Yeah, cupcakes?
No,
Okay.
no.
Of cookies. No, we don't want to. Okay,
Shit,
cookies.
of lipstick.
Lipstick. I like lipstick.
Thank you.
Wait, by moles of cookies, do you mean that there's that many numbers of?
Lipstick. We're on lipstick now.
Okay.
That many moles of lipstick. 3.8 moles of lipstick. Convert that many moles of lipstick into, this is going to sound weird, lipstick. So it's the individual lipstick.
I'm confused already.
Oh my god, I know the vocab. The words are strange. The way it's phrased is weird.
Wait. So you're saying that 3.8 times the actual number of moles of lipstick is what you are converting into one lipstick?
Into lipstick, no, I'm saying individual lipstick packages. How about that?
Wait, I have a question. Is it gonna be 3.8 times like 6.02, like that whole thing? Is that how you get it?
Yeah, that's it. Okay, that's it. Lipstick packages. So this many moles of lipstick packages into individual lipstick packages. Is that the right way to say it? I don't know. Like the little tubes.
No, trust me, I go to Sephora all the time. It's called
It's called. It is.
Yeah.
Huh? I didn't know. Okay, so I thought it was a guess. Convert that many moles of lipstick into that. Okay, so how do you do this? Well, you start off with 3.8 moles of lipstick, because that's what's given to you.
Wait, so do you put the 6.022 like times 10 to the 23rd on the bottom or the top?
What do you think?
On the bottom?
Try again.
No,
On the top?
Because
That's
then
right.
it's 1 mole is on the bottom.
So